I'm Anil Kumar, sharing with you an excellent question on functions. Now this is a thinking question. Let me write down here as tips. Question number 5. Draw a sketch of a function which exhibits the following characteristics, like all of them. Do you see that? F of 5 is 0, y-intercept at 4, whole at x equals to minus 2, vertical asymptote at x equals to 4, increasing on the interval from 0 to infinity, decreasing on the interval from minus infinity to 0. As x approaches infinity, y approaches 3. As x approaches minus infinity, y approaches 4. You can pause the video, try this out, and then look into my suggestions, right? So let me make a grid here, and then we'll try to solve this question. So, okay, so let me just draw a few lines. Take your own time to think about it and solve, okay? In a minute, I'll be there with you, helping you out on sketching such piecewise functions, right? So when we are talking about functions, they may or may not be continuous. Remember that part, right? And I hope that's a good hint to solve or to sketch a graph of the given function. Okay. So these are a few lines which will help us to approximately sketch a graph. Okay, now let's read it. F of 5 is 0. That means at 5, 1, 2, 3, 4, 5, we have a 0. So that is 1 point. Y-intercept is at 4. That means 1, 2, 3, 4. This is at 4. Okay. So here we get 5. Here we have 4. Okay. Whole at x equals to minus 2. So somewhere on this line, we have a whole, which is minus 2, right? We'll figure it out. When we draw a graph, we'll make a hole here, right? So this is still pending. Vertical asymptote at x equals to 4. So at 4, we have a vertical asymptote. So I'll draw a vertical dotted line here, which signify vertical asymptote at 4. Do you see how we read and do something on the graph to help us out? Increasing on interval 0 to infinity, that means in this interval the graph is increasing, and decreasing on this interval means it is decreasing. And then we have as x approaches infinity, y approaches 3. This means we have a horizontal asymptote, right? Y equals to 3 when x approaches infinity. So this is 3, so we have a horizontal asymptote here. When x approaches minus infinity, y approaches 4. So for this side, the horizontal asymptote is at 4. Is it okay? So these are the guidelines. Now we have to incorporate whole at x equals to minus 2. Connect these points somehow so that the function is decreasing in this interval, increasing in the other. That's the whole idea. Now if you have a horizontal asymptote at 4, the function is decreasing. How do you reach at 4? That's the tricky part. It signifies that there is a break in the function. Do you see that? So what we are going to do here is, since this is a horizontal asymptote, we can take kind of an exponential function which has been reflected approaching 4, and then we can come down like this, right? Now, and since the value at 0 is given, so there should be a hole here, correct? Now at minus 2 also we need a hole, so we'll draw a hole here also. Do you see that? So that ensures that the function is decreasing, and we have a horizontal asymptote which is this part. Is it okay? Now, so we have taken care of a couple of things here. We've taken care of that, and we've also taken care of decreasing in this interval. So it's kind of a check, right? Now we have to have an increasing function from 4. There's the vertical asymptote. So what we can do here is, let me take another ink. So this part we'll do kind of like this. Do you see that? So that becomes an asymptote. So this is vertical asymptote at 4 taken care of, increasing at least up to half the stage. We are done, right? Okay, so we've done this. Now We are left with taking care of this point, which is x-intercept and the vertical asymptote. So we could draw another function which is kind of like this, and that becomes an asymptote. Do you see that? So this is always increasing on the right side of 0. X-intercept is 5, y-intercept is 4, horizontal asymptote is at 3 and at 4. So I hope it helps you to understand how to sketch graph of a function for such complicated conditions. Now, as an exercise, what you can do is you can write domain range of this function. Okay, I hope that will help you to understand this unit on functions. I'm Anil Kumar. You can always share my videos with your friends. Feel free to post questions and like if you like. Thank you and all the best.